This presentation is entitled Affordances and Considerations Within the Design Process as outlined in the Ontario Design Technological Education Curriculum document for 2009, specifically for grade 9 and 10 students. I will focus on the goals of the programs as stated within these policy documents, specifically around the design cycle framework. To begin, let's discuss the Ontario Technology Curriculum document. This document replaces all but the computer and information science component of the document first produced in 1999. Beginning in September 2009, all technology education courses for grade 9 and 10 are based on the expectations outlined within. The goals, as stated within, of technological education curriculum are to enable students to gain an understanding of the fundamental concepts underlying technological education, achieve the level of technological competence they will need in order to succeed in their post-secondary education or training programs or in the workplace, develop a creative and flexible approach to problem solving that will help them address challenges in various areas throughout their lives, develop the skills, including critical thinking skills and the knowledge of strategies required to do research, conduct inquiries, and communicate findings accurately, ethically, and effectively. Develop lifelong learning habits that will help them adapt to technological advances in the changing workplace and world. Make connections that will help them take advantage of potential post-secondary educational and work opportunities. The philosophy that underlies broad-based technological education is that students learn best by doing. This curriculum, therefore, adopts an activity-based, project-driven approach that involves students in problem solving as they develop knowledge and skills and gain experience in the technological subject area of their choice. Broad-based technology courses enable students to develop a variety of transferable skills that will serve them well in a complex and ever-changing workplace. For example, problem-solving skills are transferable skills because they can be applied in a wide variety of situations to solve problems of various kinds. Other transferable skills emphasized in the curriculum are the essential skills and work habits identified in the Ontario Skills Passport, as the skills and habits that enable people to perform the tasks required in their jobs and to participate fully in the workplace and in the community. When looking at some considerations on assessment, the primary purpose of assessment and evaluation is to improve student learning. Information gathered throughout assessment helps teachers to determine students' strengths and weaknesses in their achievement of the curriculum expectations in each course. This information also serves to guide teachers in adapting curriculum and instructional approaches to students' needs and assessing the overall effectiveness of programs and classroom practices. In order to ensure that assessment and evaluation are valid and reliable and that they lead to the improvement of student learning, teachers use assessment and evaluation strategies that address both what the student learn and how well they learn, are based both on the categories of knowledge and skills and on the achievement level descriptions, are varied in nature, administered over a period of time, and designed to provide opportunities for students to demonstrate the full range of their learning. They are appropriate for the learning activities used, the purposes of instruction, and the needs and experiences of the students. They are fair to all students, accommodate the need of students with special education needs consistent with the strategies outlined in their IEP, accommodate the needs of students who are learning the language of instruction, ensure that each student is given clear directions for improvement, promote students' ability to assess their own learning and to set specific goals, include the use of samples of student work that provide evidence of their achievement, and are communicated clearly to students and parents at the beginning of the course or school term and at other appropriate points throughout the school year. In many technological fields, open-ended, problem-solving processes that involve the full planning and development of products or services to meet identified needs are often referred to as the design process or the design cycle. A design process involves a sequence of steps, such as the following. Analyze the context and background and clearly define the problem or challenge. Conduct research to determine design criteria, financial or other constraints, and the availability of materials. Generate ideas for potential solutions using processes such as brainstorming and sketching. Choose the best solution, build a prototype or model, test and evaluate the solution, repeat steps as necessary to modify the design or correct faults, reflect and report on the process. Although processes such as this involve a framework of sequential steps, they are typically iterative processes that may require a retracing of steps, diversions to solve specific problems along the way, or even a return to the start of the process if it becomes clear that the situation needs to be clarified and the problem redefined. Problem solvers soon discover that the process calls for an open mind, the freedom to be creative, and a great deal of patience and persistence. Please watch this video of a grade 10 robotics project at a school in Ontario. You will see that the building of this robot follows the design cycle.
Me and my partner built a robot provided by our teacher, the purpose of which is to climb stairs in any case. The design that me and my partner finally built was very different from the ones that we had put on paper, such as these. The final design that was created was this one right over here. After creating this design, we figured that this would work perfectly, and it did. At the back, there is only one servo, and at the front there are two servos. In the middle, pointing down, is a color sensor which can sense a red tape, which would make the robot stop. The design is shown briefly in this diagram right here. We have two stoppers kind of things which would stop the whole robot from tipping over. At the back, as explained earlier, there's only one servo. There's a color sensor pointing down. There are two servos. It also explains over here that as over here, when the front gets pulled up, the back would get pulled up by the front, so that it would be easier for the robot too. If we had more time in this project, we would have added more parts to make the wheels more stable so that the robot wouldn't fall apart. And we would have added more things like the sensors so that the robot could sense everything that's around it. And we would have tried to make it a bit more cooler so that it looks good. And according to my wish, we would have made it more so that it would look like a Batmobile.